presentation is organized in this following subheadings. We start with the overview of Markov chains, and the method of estimating transition property matrix has briefly been explained, and that is available 8 minutes from the beginning. To give a numerical illustration of how the mean absolute deviation works, that is available in the 12th minute. Preparation of data for the MAD, which is very important, is available at approximately at 17th minute. And there is an app that helps you to develop the equations very fast, and that's very critical for this whole analysis of preparing transition property matrix is available in the 23rd minute. I've used a software called LP Solve ID, which is a free software which you can download and use to solve the problems. For that, we use the app to develop the equations, and the equations are solved using the linear programming framework. That's available from the 25th minute. And preparing the probability matrix after the result has been obtained is available on the 26th minute, because that gives you that M into M matrix. And finally, some applications of the transition property matrix is available from the 30th minute till the end.
Markov chain is a technique, it's a stochastic process, which is good for modeling systems which are in the process of change. So it basically, it is a model that is used to study any system. It's like, for instance, you're studying a system and you want to see how changes are taking place. You normally use a Markov. Now, though the concept of Markov chain is very simple, and it was developed in the year 1906 by Andrei Markov, with the goal of showing that the law of large numbers does not necessarily require that a random variable to be independent. Since then, they have become extremely important in a huge number of fields such as biology, game theory, finance, machine learning, statistical physics, and so on, in marketing, in policy modeling. They're also very widely used for simulations of complex distributions by algorithms such as Markov chain, Monte Carlo. Since Markov chains come from independent and identically distributed sequence of random variables, x0, x1, x2, xn, where we can think of n as time, right? So with time, you go on moving. Independence is a strong assumption. It means that xj provides no information about others. At the other extreme, allowing general interactions between xj's makes it very difficult to compute even the basic. Markov chains are a happy medium between complete independence and complete dependence. The space in which Markov processes live can be either discrete or continuous, and time can be either discrete or continuous. So you can use both in continuous and discrete time, but you have to assume cohorts so as to make it discrete. So we will focus on a Markov chain x1, x2, x3 in a discrete space and time. Continuous time would be a process xt defined for all real t greater than 0. So most of the ideas can be extended to the other cases. Specifically, we will assume that xn takes the values in a finite set, that is state space, which we usually take to be 1, 2, 3 to m or 0, 1, 2, 3 to m, if it is more convenient. Okay, so this is what Markov chain is all about. The Markov chain is a stochastic process. Created by Andrei Markov in the year 2019, states that outlines the probability associated with a sequence of events occurring based on a state in the previous. So it is very common and easy to understand, that is frequently used in industries that deal with sequential data such as finance, marketing, even Google PageRank algorithm, which determines which links to show first in a search engine, is a type of Markov chain. Through mathematics, this model uses our observations to predict futures. So basically, we just try to see what is our behavior and how it is changing over time, and then try to use it to predict it in the future. The main goal of a Markov process is to identify the probability of transitioning from one state to another. Now, this is very important. So in a Markov chain, we have different states, and we want to know over a period of time, how are we moving from one state to another. So one of the primary appeals of Markov is that the future state of a stochastic variable is only dependent on its present. An informal definition of a stochastic variable is described as a variable whose value depends on the outcome of the random occurrence. So the current value of the variable depends only on its immediate past. So the presentation includes discrete time Markov chains, a type of stochastic process used to model systems that evolve randomly through time, through a sequence of events. So the evolution is what you notice. And the underlying reason why they evolve is for you to understand. There is an underlying reason which is making them evolve. And that is what is studied using a Markov. The key characteristics in the Markov property is the Markov property, which states that the future state of a process depends only on the current state, not on the entire history of the events leading up. So this is a very, very short-term memory kind of model, which is attractive, as my demonstration will show you. So the behavior of these chains can be governed by transitional probabilities, often represented by transition probability. So central to Markov chain analysis is to estimate the transition. So once a transition probability matrix is estimated, you know exactly what you will, which specify the likelihood of moving from one state to another in a sequence. So depending on your time intervals, for that same time interval, transition probability matrix will tell you what's the probability that you'll shift to another. My example will help you to understand this a little. So we show how to calculate probabilities for events further in the future using minimization of MAD. That's a method we use. We show that the probability of reaching a state n can be found by multiplying the transition by itself. So I'll explain that and as we go. So it's a stochastic process in discrete time. We convert it to this. So an excerpt from Wikipedia defines Markov as a type of stochastic process where the likelihood of a future event depends only on the current state and not on a prior history. So the sources detail different types, such as discrete time and continuous time Markov chains, and discusses the mathematical properties like transitions and stationary distributions. It also highlights numerous applications across diverse fields, including psychology, biology, economics, and even text generation, sports. So it's got a lot of application. The Markov chain is a stochastic method earlier used to predict the probability of a future event based solely on the current state. It explains that a key feature is the memorylessness. So it doesn't require a big history. It just requires your immediate. So meaning the past history doesn't influence the next. It's just what you went now. And my example will help you to illustrate it. So the piece details how to build a Markov chain using a transition matrix and an initial statement. So these are the important things that you have. You should get the transition property back. You have to evolve it, and that is the great challenge. So I illustrate this not in text prediction, but in international trade, in commodities from India, agricultural commodities from India is what I am going to show along with a few Python and other code. So the main characteristics of a Markov chain are memorylessness. The term memorylessness in mathematics is a property of probability distributions and generally refers to scenarios in which the time associated with a certain event occurrence does not depend on how much time has already elapsed. In other words, the model has forgotten which state that the system is. As a result, the prediction associated with Markov processes are conditioned only on its current state and are independent of the past and the future. The memorylessness attribute is both a blessing and a curse. Imagine you wish to predict words of a sentence or a sentence based on the previously entered words, similar to how Google does it in easy. The benefit of using the Markov process is that the newly generated predictions would not depend on something you wrote paragraphs, but what you wrote recently. However, you won't be able to predict the text that is based on the context from a previous state. So this is a common problem in natural language process and an issue in that many models face. Now, how do we create a model? So Markov chain depends on two key informations. One is the transition property matrix and the other is the initial vector. So I should know what is my current state. So the transition property matrix P is an n-to-n matrix where n is the number of states. Okay. So note that a direct connection connected. So you have a graph. You don't need not show the graph. You can just kind of understand. You'll have an initial vector. Now initial vector will be n into y. So what am I currently? What is my share? So we have n states. Now, state is a variable. It's like a variable. Okay. So your initial vector will be n. Okay. So given the two dependencies, you can make the product of p into 1 to determine the initial state of the Markov. In order to predict the probability in the future, you can raise your transition property to the power of n. So once you get the transition, now this is the great challenge. In most of our programs, in most of the research, it's very difficult to estimate the transition probability. Transition probabilities can be estimated provided you're collecting the data directly. What did you use last time? What did you use? Where did you go for a holiday last time? Where did you? When you have aggregate data, when you got aggregate, see how the transitions have taken place, and calculating the transitions is the challenge. And what is very unique particular. So we have a transition process that I show you as we go along. We have a where it's an array of numbers. It's a matrix, n into n matrix, or an m into n matrix, where you have n states. Okay. The individual properties are written as Pij, capital Pij, where a probability Pij tells you what is the probability that you move from state I, which is in the row, to the state J, which is in the column. So essentially, you have to calculate that transition property matrix, and then a lot of useful things can be estimated. Now, the biggest challenge about using the Markov chain models is to estimate this transition property matrix. Very, very difficult. Most of the papers don't deal with it. Most presentations do it. I'm going to show you a simple example how you can estimate The transition property matrix, when you have aggregate data. Now you minimize the deviations, I, I is an identity matrix, E is the error term of the deviation. Subject to XP plus V is equal to Y. GP is equal to 1, where G is a grouping matrix, X is a matrix of lagged values. This X is a matrix of lagged values. I will show you this with an example. You'll understand it better. G is a grouping matrix in order to make the transitions add up to 1. There's an addition. The conditions of a transition, the probabilities are Pij is the probability of shifting from a state I to state j. Pij will always be greater than 0 and less than 1. The value of Pij will always be greater than 1, greater than 0 and less than 1. And the sum of the Pijs along a row, we should add up. That is what he's talking about. Aggregation, the last objective is. Okay, I'll show you this with a very, very small example so that you can understand it better. So put it a little more technically, this is what it will look like. And what you get out of this is the transition property matrix Pij, which you can see over there, which is arranged in the M into M matrix, not M into N matrix, M into M matrix. Summation Pij is equal to 1 and the Pij's range between. These are the basic conditions you should know when you do this. Okay, so that is it. So I think that's what I'm going to tell you. So now we will go straight into the presentation. Now let us look at the data. Now the situation that I'm using over here is I'm trying to model India's exports of agricultural commodities to various countries of the world. That is my job. That is what I'm. This is my data. Now I download this from International Trade Council. There's a website called International Trade Council, Comtrade Statistics, and here I get data of India's exports to various countries. As you can see, I'm just expanding this. India's exports to United States, United Arab Emirates, to Netherlands and so on. This is exports of total exports from India to other countries. Yeah, let's see what it is. List of importing markets for products exported from India. That is total value of exports in dollars. I asked for dollars. And this is the export side. Now I want to see how this transition is taken. So my states will be these. These are my states of my transition probability match. And I want to know from which country to which country is our export shifting. We want to see the switching behavior from one country to another. So I'm going to use a Markov chain. So when I use a Markov chain, now this is my time-dependent data. So I will just take world exports. Let's just take world exports. And I'll put a graph and you can just see in Excel itself, put a graph. This is how our exports are going. But I don't know. Let me just show you America. This is our exports to America, United States of America. America, it's growing. It's great. I'm talking about exports. I'm not talking about exports. We're talking about exports. And exports to America are growing at a fairly rapid rate. So now I'm not interested in seeing what is the exports to America. I want to know how is the share of it. So my variable becomes not the quantity of exports, X, but it becomes the share of X. And the share of exports follows the transition problem. Okay. So my dependent variable is share. So Markov model is a very simple model. It's a very simple model. I'll just show you how. So let's say there are just the three brands. Brand 1, brand 2. I just want to show you how it works. And I've got data for 2010, 2015, 2020, 2020. So it's a simple example for you to have. So let's say brand 1 as a total listing of 12, some 12 million. This is 50 and this is 8. Okay. In the next year, this 12 became 15, this 15 became 25, and this 8 became 50. Okay. Then this became 17, this went to 30, and this went to 20. And in the current year, the 17 became 22, and this 30 became 40, and this 20 became 20. Now, to find out which brand is graded over which brand, it's not that simple. Okay. So what I do is I convert this into this. I first work out the share equal to sum. I'll work out the sum. And for the same brands and for the same years, what I will do is I'll work out the share. Because this, I'll work out the shares. Okay, what will be the share? So it'll be this divided by this. And I'll fix it. This divided by the corresponding row total. So this particular brand has a 34% market share. This has a share of 42 and this has 20. I've done it in such a way that they'll add up to 1. You see that? Okay, so let's start worrying. So these are the shares. Now what you can see is actually brand 1, though the quantity is increasing, the share has come down from 34 to 25. Brand 2 was from 42 has gone to 40 and brand 3 has increased from 20. Now you want to know how these transitions are taken. And for that I need a transition property matrix, which will have, it's a square matrix with brand on the row and the column. Now roughly what we do, the method that we are going to use is called the minimization of absolute deviation. So these current values of brand 1, I'll just show you like an equation. Okay. Now this value 0.27 is because it was 0.34 in the previous period. This was 0.42 in the previous period, and this was 0. Similarly, brand 2 decreased to 0.25 because it was 0.27 in the previous period, that was 0.45 and that. So what we're trying to do is we are trying to create this matrix. So just see what I'll do is I'll take the, look, I'm leaving out the last values and I'm taking the current. So this is for brand 1, this is for brand 2, okay, and this is for brand. I'll put it in different colors so that you'll be able to see. This is the shares of brand 2. This is brand 3. This is the shares of brand. Okay. Now, now this depends on this and this. So I'll take this one. So this second value 0.25 depends on this. I take this and I put it. And 0.25 depends on this. Now coming to this. Now this also depends on the same. But what happens is this should be shift because it's a different variable. This is a different transition. So this depends on all this. So we have the same variable. You notice that they're just repeating the same. This depends on this is a Markov process. Yt is a function of yt minus 1. Okay. And the third one depends. Now it's very easy for you to understand that these coefficients are the same, so I can just go and repeat. This is how the minimization of absolute deviation works. So this I will call it as P11, P21, and P3. In other words, it gives me the first column of the transition property matrix. This I'll call it as P12, P22, so, and this will be P23, P3. This will become the second column, and this becomes the third column, P13, P23, and P3. Once I solve this as a linear programming, this will become my first column, this will become my second column, and this will become my third, and this becomes my transition. This becomes my transition. So now I'll add deviations, I'll have positive and negative deviations. I'll put a 1 and a minus 1. Okay, 1 and a minus 1. I'll keep shifting this. I'll shift it to two columns that side and I'll put a minus 1. I'll put minus 1. These are nothing but slack variables. These are slack variables and one more. So this is what I do. I'm going to show you a simple method to do. Now, here what I do is in my objective function, I'll put a 1, 1, 1, 1. I'm going to minimize this for minimization of absolute deviations. These coefficients will be 0. If you recollect what we did in the presentation, you'll understand. This is this. We are deviations. This is a V, Y, GP is added addition. And what is that added condition? So this is a matrix. I'll take this out. This is my transition property matrix, which I've been will be involved. Now what I want is this coefficient, because the row should add up. P11, P12, and P13 should be. So this row, this should add up to. So that's what P11 plus P12 plus P13 should add up to 1. Here again. And here. So this, if I solve this, it'll add up. Okay. Now, this is called the minimization of absolute. This is a challenge, very, very difficult. People find it very difficult to solve linear programming problems for this reason. They think it's very, very complicated. Actually, it's not. But there is some procedure to be followed. So rarely do we get in examples, you don't get this method to solve transition property matrix. They assume a matrix and they solve. I'll just show you how it works. And these are my deviations. D1, 2, D3, D6. Okay, these are my deviations. They're all taking positive sign. So this is the method. If I solve this as a linear programming, this is my objective function. Objective function. These are my this is my objective. These are my objective function coefficient. These are my constraints. And when I solve it, I have to arrange it. This is my constraint. If I get the results for this, I will arrange it as a transition property matrix, and that's what I get. Okay, it's rather easy. So I'm not going to show you. So this is just for you to understand the concept. Now I will go to a real life example because you should get used to working with big data and things like that. So now I'm going to show you how to solve. Here we go. I'll go back to the data. This is my data. Let me show you. My data. So now try to replicate it for the same thing. So the name of this file is called export. It's called export. It's India's export. So now we'll go straight to Python and we'll go to Markov Chain. No. Okay, I will go here and open Python to show you how it is done in Python so that you can implement it. But the advantage of this method that I'm demonstrating to you is you can estimate the transition property matrix, which is otherwise very difficult. It's a little difficult to estimate because of the amount of computing you have to do. But we have simplified it, and then I'm going to demonstrate it to you. I'm just opening Python. This is the data. You can notice that the data starts from the 16th row. The data starts from 16th row, goes right down to the data is starting from 16th row. So I'm going to show you how I'm going to do that. So here we go. Brain matrix. Here I've done it, and I mark. Okay. So what we do is these are the usual pandas for importing data. NumPy for manipulation, math.lib, and OS I run that. My file is in my file is called exports. Now I got a folder called exports, which I directly access. I create the path. I create a path to give my workspace. Workspace is here exports. And in that exports, I've got a file which I just showed you, which is called India's exports XLS. And I'm starting from row 16. Therefore, I say skip 15, 16. I do that. And then I'm having a look at the data. When I look at the data, I notice that the data is like this. It's already done it, actually. Okay, now what I'll do is I'll transpose this. Okay, I'm going to transpose this, right? Because I want the years in the row. So the name of the file is df. So I create a new file called df_t. which is nothing but the transpose of DF. I transpose it, and when I look at the data has come. The years are here at the very end. Here, okay, I've transposed it. Yeah, this is the one. So when I transposed it, I notice my columns have come to the second row, and my data, my column variables are 1, 2, 3, 4, 5. I want to take it off, go to ChatGPT and get this command. I say df under dot columns I dot o. That means it takes the first value as the row, and then it takes the first row as the column. Reset index top drop true. Okay, so what it does is it first creates dt, okay, and takes row 0. That is, row 0 is the first row. In Python, the row 0 is the first row. So it takes this row and puts it into the column. That's what it does. So it's a d of the column. It is in the first row, and it says reset the index. I do that. Okay, and then what I do is what you notice that my years are all in like this. Export value 2005. This is not a number. I want to convert it into a number. And how do I do that? I use this command. I'm going to create a new variable called year. And I say np.arange, starting from 2000. To that, I will add the shape. I run that. And now when I look at the data, you will see at the very end that it has created the new variable time. Because Markov models are time dependent. Please remember that. Markov is a process that changes with time. Okay. Now what I want to do is this command I got it from ChatGPT. I said, take this data, take the data which is only accounting for 60% and put the others under others. Because here, if you look at it, I've got 229 countries to which India is exporting. It becomes very like even countries like Neo, Crane and all that, which we don't even know. So what I tell you, I've used the help of ChatGPT, and I said, don't convert world, don't convert year, but account for 60%, cumulative 60%, give me the countries which account for 60%. It's done it. And I said, you can put the world total, which is the total, at the very end. Okay, and I run it. And now you see a database which has got 229 columns gets now reduced to, you see the shape. It now gets reduced to 18 columns. So there are 18 countries to which India is exporting principally of all countries, not only aggregate. Okay, we know the file. The name of the file, I call it df.data, df_data. Right? And when I look at the bottom end of the table, look, I've got the year here. And you'll notice I've got, this is very important. The last column should be the total. Okay, the last column should be the total. Okay, I've done it. Okay, and I'm just looking at which are those countries. So I say df_data.columns, and these are the countries: United States of America, UAE, China, Singapore, Hong Kong, down to others, and then, right? Now this is where, now I've arranged the data. Now just like that example I showed you with brand 1, brand 2, brand 3, now I've got essentially 18 countries to which I'm exporting. India is exporting commodities. Okay, right. So here, yeah. So we've got 18 countries. Now what I do is, since the data is in my usable form, now I write it as df_data.csv. So I convert this df.data into a CSV file, which will be available in this folder. Get current work directory. It says here. Now in exports, look for so it is now in exports. Now I just look for this file in the exports. Click it here. Go to export and look for the latest. I just say the latest. Yeah. Look, it's reduced to what is the last one. This is the format I want. Please remember this format I want. Want it number format. Let's show it. So this is our exports to different countries. So India. I'm showing you the real example. Data from 2005 to 2024. Roughly 20 years later. And I want to know how my objective is to find out changing from one country to another. I'm not vouching for the validity of our Markov chain for using this data, but I think it is good enough, and just to show you how the technique works, and that is why I'm showing you how it is done. Okay, now this is the data that we got. So please remember the name of the file which I said was df. It's a CSV file. It's ds.csv. Okay, so there it is. So now come back here. This is important. This is where we digress from most programs. Now, a student of mine and a friend of mine has developed a program called, to develop these equations. Those equations that I told you, that I showed you. Now that has to be converted to equations. You remember how many equations we got? If you got to convert this into an equation, that is the 0.34 into P11 plus 0.33, 0.42 into P21 plus 0.22 into E1. Plus D1 plus D2 less than or equal to this, all equal to. So this becomes like a linear programming. It all becomes equal to, including this. It becomes equal to, and then you have to have a look. So then, that being the case, it's a hell of a job. Okay, it's a very, very big job trying to do that. So if you use this, I'll share this with you in the link. In the link at the bottom, I'll share this program with you. so that you can also use it. This is developed by a friend of mine, Dr. B. Ravi Prakash, a PhD student, right now PhD student, Dr. Mr. Manoj Patil. So he's developed this program. So he says, this program that you just developed, this file that you just developed, this is developed, okay? He says, bring this into that file. So he says, go and bring it. What I do is I go here and he says, browse file. Okay, I'll go here and I'll go to the first CSV. This is the one that I'm going to use. Let's say open and then this. Now, this program will generate those equations, which is a daunting task. Getting those equations is hell of a job. So what it's telling you is the variable start, I don't need here. So I should start from 3 and I should end with the total 19. So the columns should start from 3 and end with 9. The row should start from 1 and end in 20. The row should start from 1. We'll just see that here, not visible, and end in 20. Starting, presuming this is 1, this will be 20. Starting from 0 is 90. So it is going to start from 1 and end in. Okay, start at 1 and end. That's all you have. Okay, then I say that in a jiffy, you get this equation. Now these equations are very, very important for you to run them. So he's giving you a command, a copy command. So this is one reason why most examples they're not able to show you the transition problematic, but they assume a transition. Whereas you don't have to assume it. You can use it readily, which is already available. Now, we are not going to solve this in Python, though you can. There's another package called LP-Solve IDE. So go to Google, okay? And this is a free bed, and this is called LP-Solve IDE. Okay? It's called LP-Solve IDE. There, you can just download it, and it will show you how to download it. So you can just go there, read about it. It's a free bed, so you can access it anywhere. Yeah, it's it out. You go there, and without any difficulty, it'll download. I'm not downloading because I've already downloaded it. I have it here. I'll share this all with the link, so you here. Now I'll copy the equations. I'll just copy this, and I just paste it over here. You'll notice a huge thing. It goes to 679 rows. All with just one click, you got it. And you come here and you just press add. Go to results. Done now in GP, all in a GP. You go here and you go to file and you say export results in CSV form. That's it. Okay, it will be there in exports and this you call it underscore transition property matrix. Now go to the same thing here and you open, go to this. You know it's in export. But the problem is sometimes it won't show up. Okay, so what you do is just say star and say open. Then it will show Markov T. This is what so we go this page. Now here we have a transition property matrix right down here, right along the file. Just jump here. Yes, must be semicolon. That was a mistake. Now, this you must be very careful. Now, this U's and V's that I've created over there are the deviation variables, so which I call D over there. There's a positive and negative. All the U's, the positive are called U's, and the negatives are called V's. So I'll eliminate it from the output. So take it right down to the bottom. Till the U's and V's ends. Okay, the U's are over. Now the V's. Now X starts here. Take this out. Control minus. Now you got only the X's. Right. So what you do is you come up to this X1. This is X2. Now copy this down to the bottom. Control X and paste it here. Keep this down to the bottom. Control X and paste it. And you have to do this manually. Yeah? Up to 1. Can you see that? Where it's ending is the 1. When the 2 starts. Then after you do it mechanically. If you want, you can write a macro, but if I write a macro, you'll find if you'll have difficulty. Some of you may have difficulty understanding what I've done. So what I'll use, I just there are 16 states. I remember there were 16 states. So I'll have to repeat this 16 times so that I'm done with it. That's because this will help you to understand. I can write a small macro and this will automate it, but that could lead to some kind of ambiguity among some. Control X, Control V. When it ends, it ends somewhere in Q. One more. Okay, it'll end somewhere in. But you should align it properly, otherwise the whole thing becomes that's okay. So this is my transit. This is the difficult part. In any in any study on Markov chain, this is the challenge which most people find difficult to estimate because they don't have that equation. Okay, so I'll take number and I'll just take 4 digits. If I say okay. And here, what I'll do is I have the other. I'll take the names. Okay, I'll take these names. These are my names. The same order. I don't need the total. I'll take the same order, paste it over here. Right? So these are this is the transition property matrix. This is the transition property. This part I don't require. Right? And I've got the transitions. So the transition property matrix tells me what is the transition. It's a square matrix, as I told you. Square matrix, right? As many rows, values you have in the row, you have. There's a 0.72 probability that exports to America will retain in America. Will be retained in America itself. So the 0.72 probability that exports to America will remain to America. 0.67 probability that export value to UAE will remain in UAE. China, look, the export retention is. If you read the transition probability along the row, you know which are your losses. Exports to America will switch to United Kingdom. There's a 0.04 probability. The 0.04 probability that what India is exporting to America in the next year could switch to United Kingdom. Okay, the biggest one. Now let me look at the biggest one. Now there's a good chance that we'll switch to Belgium also. And now, okay, now let's take UAE. Exports to UAE is not as stable as our exports to America. But there's a 0.1 probability that our exports to UAE can switch to Singapore. 0.11 probability that exports to UAE could switch to Hong Kong. Okay, so on and so forth. So the diagonal elements gives you the retention problem. Retention, what from one year to another, exports from this country will continue to the same country. Singapore is only 0.44. Hong Kong is 0.49. United Kingdom is 0.28. So Netherlands is 0.73. Could be flowers, Germany is 0.17. Saudi Arabia is 0.26. And Belgium, absolutely no blood loyalty. Bangladesh, yes, 0.45. Italy is very little, 0.709. Japan is even less, surprisingly. And the others is 0.82 because others combines everything, accounts for about 40%. This transition property matrix, right along the row, tells you the losses. Right along the column, tells you that. Now, United States of America has a brand retention of 0.2. And there's a 0.36 probability that export from Bangladesh will switch to America. So the column tells you the gain. There's a 0.66 probability that exports from Malaysia will shift to America. Let us take China. China, we have a retention probability of only 0.27. But there is a 0.26 probability whatever we are exporting to China, to Singapore could switch to China. 0.78 probability that what we are sending to Japan or Germany now could switch to China. So the row gives you the losses, columns give you. Okay, this has to be clearly understood. Now, let me go a step further. I'll go back to this sheet. Now you understood the transition property matrix. You will notice because of the way we have constructed it, the rows will add up to 1. You just see, I add up the rows, the transition problem and the so kind of structure. That will add up to 1. The sum adds up to 1. Right? So there's no problem. All the probabilities are less than 1. So all those conditions are satisfied. Now let us use it for forecasting. You said we discuss now that it can be used for forecasting. Now let me take these countries. I'll take this sheet itself. I'll take this sheet. I don't need world. I need just this. The transit problem. I'll paste it. Okay. So these are our actual exports to these countries. Okay. These are actuals. Okay. Now I'll calculate the predicted. Let's see how good this is. Okay. Now these are predicted. I don't need this. I'll take out this because I'm going to predict. Okay. So select the same area. Select the same area as this. Up to others. You do not have total. Select the same area. Block it off. And then you do what is called a matrix multiplication. In Excel, it's equal to MMUL. The data. This is the data. Don't know the year. Just take the data. Comma, multiplied by the matrix. Data multiplied by the transition. Close the bracket. Don't press enter. Control shift enter. Now control shift enter. Size should be exact. Okay, this comes up to equal to first array. It's asking for the first array. Comma, second. This is nothing but it. And control shift enter will give you the text. Now I have got these are the actual shares, actual exports, it's converted to proportions, and these are called the predict. Now let us see how they let us take let's take America. Are we having a trade problem with America? Let us take America actual. I'll paste it over here. And this will be America predicted. I will not say America predicted. I just say because here, please remember when you copy it, there's a formula. So you must do paste special and select only the value. Because if you just paste it, it will show values. This is actual and this is not. We just see the graphs. Almost bang up. So actual is blue, predict is pink. So for example, we'll turn around and say, now, when you predict it's 1 period ahead, I'll shift this 1 period ahead and then still see that the values are not very wrong. There, again, see the actual and predicted. Exports in dollars to America, $1 million, I think lakh dollars or $1 million. That is very good fit to the data, right? Now I will show you China. Let's take China. So let's take China. And China predicted is here, but I told you there's a formula. So what happens is we just paste it one down. If I paste it just like this, it'll show error. So I'll undo it and paste special and actual and this is trend. Not so good, but it gives you the trend. The trend is not wrong. And boy, why I'm showing you this is with this can I interpret the transition property because we are going to interpret how the shifting is taking place. No, this is for China. I'll just show you for the second biggest exporter is UAE. Just overwrite it. UAE, that's your actual. UAE predicted is here. When you do the predicted, because it predicts one period ahead. No? That's why I'm showing it here. That's your base special values. UAE is also. So, having seen these figures, the actuals and the predicted, I'm very convinced that the transition property matrix, which is the basis for getting this, can be interpreted properly. Okay, now I want to know what are their shares. Let's take these countries. These are the countries that we are studying. This is exports of commodities from India. Now I want to know currently, what is this thing? I want to know currently, I take it politically. Okay, these are the actuals. So what I'll do is I'll work out an average. I'll do an average. I'll take a triennium average. 3 years, I'll take a triennium average. Take a triennium average for the last 3 years, right? Okay. And I'll express each as a share. I'll take a triennium average. I'll express each as a share. Let me just take this, let me down. Okay. So what is the share of this divided by sum? Well, I don't have a column total now. I'll take a sum. Fix it. We have 4. So I get the share. That's because it's made it 1 digit. Now make it back to number. Make it two. So America's, in the last 3 years, America's share of the total exports is 18%. 18% of exports are to America. 8% of our exports is to UAE in the last 3 years. China has about 4%, and you can see Singapore has about 3%. I'm talking of all exports. All are quite low. So this is a share he's talking. So we get the share and we get the transition property matrix. And if I want to predict maybe 2025, I want to predict the 2025 shares, select this range and say equal to MMULT, like share multiplied by transition property. Now the transition property matrix has got a lot of credibility after we saw the forecast. Now we saw the forecast and we said the forecast, the transition property matrix is able to forecast reasonably well. So I have no reason why I have to doubt it. And Control Shift Enter only will give you the share. So this is the share in the year 2020. Let us take 2020. Like this, I can go on forecasting. Now, 2026, what I'll do is I will take MULT, take the previous comma, multiply by transition. Control Shift Enter, not just Enter, which will give you the share for 2024. Gosh, sorry, very mistake. Okay, very mistake. So take the whole thing equal to MULT, multiply this whole thing, whole row, multiply the transitions. So this is the share. Shall slightly come down to America, maybe 2027. If you want a long forecast, then you have to raise the matrix. Okay, I'm not going to show you. I'll just show you because the same thing you can expect. 2027 will be, take the share, same thing, equal to MMULT. There it is. This share, immediate precedent share, comma. That's it. This first, that's come to 17. I'll do for 2 more years, and 2028, 2029, and 20. Because we need a little bit. So please see the procedure, what I'm doing. Select the whole row, equal to MMULT. This multiple, this matrix, tap the right place, and then see. Control Shift Enter gives me the share. Okay, so I've got to 28. I'll do 29. So that's equal to MMUT. We can take the precedent. It's one step. They say it's one step ahead. From this, we know that America is a big trading partner for all commodities put together. We got to underline to the last one, completed equal to. The American share exports are coming down because of the transition that's taking place. You see that America's exports to America are slowly coming down, 17% to 16.9%, right? So then, okay. Now you may say, look, this does not give me the real correct picture. Now you can kind of this thing. Well, let me take these years. Okay, let's take it and put it right. So now you got the shares. Now, how do I convert this into quantity? To convert it into quantities, what I'll have to do here is I should go and forecast this total world. I'll get the world. I have the total world. This column and take it, and then forecast that because I'm working with shares. So when I work with shares, there's a total world. Okay, so that world exports. So now what I can do is I give the total. So this is for these years, 24. Then I want for 25. So 20, 26, 2027, 2028, and 2029. Right? So I'm going to just take those years. And I'm going to forecast. So I should be careful when I forecast because I've got shares of total exports. Now I have to forecast it for the coming years. Or you do that. I'll just show you in a moment how that's done. Okay. Now to get the forecasted exports, first, I will have a look at the exports. How is the exports behaving? I'll just look at this, a graph of this. Okay, I'll take world exports, I'll do an insert, and I will see how the exports. Since it's almost a linear increase. It's almost a linear increase. No, it's not exponential, it's linear, right? So what I'll do is I will go for a linear export. So I just say equal to forecast. You can use any method. There's nothing forecast. There's nothing rigid about it. Forecast. It's asking you which value. I say I want the forecast for 2025. Then it asks you what is your Y value. Y value is my total exports. I'll fix it with F4 so that I don't have to do it every time. Comma. And then it's asking me what are your X values. My X value, of course, is time because I'm doing a time independent thing. That's my time. F4, right? Close it and enter. Yeah. So it says 44,080. So it's done a linear forecast, right? It's done just a linear forecast, and I'll drag this down because I have fixed these things. So I know my forecast in the year 2030, since I've got 2030, right? 2030 is, I will drag it once more. It's come up to that. So my exports, which is 444170612, is going to increase to 52. Now I'm going to convert these percent. So this proportion into this forecasted quantity, which is on the top. So I'll have to fix it with, I do the F4 so that I can get the column fixed, so that it doesn't shift to that. So now you use Markov chain to forecast your values till the year 2030. After the transition probability, which is the biggest challenge, it tells you what is going to be your forecasted value of exports from America using the transition probability matrix and the matrix. It is not like extrapolating a trend. It looks at the dynamics. So you're now seeing how it will, because this will be a linear forecast, because that is what's going to happen to forecast to UAE, to America. I just shift this for want of time. I just shift this here. This is what's going to happen to exports to UAE. This is what is going to happen to exports to China, which is going to increase. America is slowing down, if you see. Singapore is going Singapore up. So this way, we can forecast using Markov chain, which actually considers shifts from one sector to another. It's not as if you're making a linear extrapolating the trend. No, you're not doing that. You're looking at the dynamic. Okay, so this is what you do in Markov chain. And the more important thing that I want to impress upon you is how to estimate the transition probability matrix, which is really the challenge. So in order to estimate the transition probability matrix, you have to get this. I'll share the codes. You can get it. So to get the transition probability matrix, first I should arrange the data. And please remember to do a Markov chain, all the states. Now, the states are, in this case, where the variable is located. If you're doing it for returns, it will be returns, different types of returns. When you're doing it for exports, it will be country. If you're doing it for land use changes, it will be agriculture land, non-agriculture land, forests, and all that. Okay. So the states are the condition in which the variable exists. Right. So states can change depending on if it is a brand switching, brand loyalty, brands will be there. The important thing about this is states should be inclusive. You can't do it for just United States, UAE and China. No, you have to do all. You should have one column for others, and the total should be the grand. Whatever situation you're studying, the state should be mutually inclusive. That means all the states should be included. Second is, there is a property called it's called ergodity. Ergodity means that you can shift from any state to another state. Now, when you talk about exports, you can go from America to any other country, like our transition probability matrix told you. This is a condition. So unless this condition is imposed, it can go from America to anywhere. It can go to any state from one period to another. You're talking of one period to another. On an average, it's moving from America to Netherlands. So it can move from any state to any state. That's called ergodity. And the third thing is that condition of the rows adding up to 1. Right? So this is what I basically wanted to explain to you. I will put the codes. The codes will be available in this required. You should just copy this, paste it to your browser, and keep the file ready. The file would have been generated already in Python, or you can do it in Excel also. There's nothing rigid about it. Yet it need not be. Only thing, it wants all the columns, and the last column should be the data. So this Markov equation generator is very, very important, because generating the transition probability matrix requires. So without that, you cannot estimate the transition probability matrix and all the calculations that you saw. Okay. So with that, I'll wind up. And thank you very much.